rules. So what is exponent? First question arrives. What is exponent? Exponent is what? Most of you, I think so. Most of you know about it. Okay. Exponent. Here, let me explain about it. Exponent is known as power as well. Okay. So here, exponent and power. Meaning of this and meaning of this is the same. But exponent is used as a formal word and power is used as a simple word. But whatever you can use. So whenever there is a talking about exponent, so just understand. But exponent which means power, power which means exponent. So our topic is going to be this. Here. This is and about it we are going to discuss. So here, how to identify where is the exponent. How to identify where is exponent. So in this case, we have two things to know. First base and the second exponent. Did you understand? In this case, we have two things to know. What? Base and exponent. Base is 2 and exponent is 5. Okay. So always remember, downward number will be known as base and upward number to the downward upward number over the downward number will be known as exponent. So this upward number will be known as exponent. So always remember, this is exponent, otherwise you can say power, and this is base. Okay. So if I ask you, here tell me, what is what is the base and where is the base and where is the exponent? You would say 10 is exponent, 10 is exponent, and 5 is base. Here, this is how we identify exponent and base. Clear? And in the context of exponent rules, we will be discussing ahead. Clear? So it means meaning of this is exponent means times. Meaning of exponent is times. So how much times? 5 times. What? 2. 2 will be written 5 times. How much time? 5 times. 1, 2, 3, 4, 5. So 5. So exponent would say, yeah, just write your base how much time? 5 times. In this case, this 10 is saying that just write base, whatever you have a base, 10 times we will write our base. How much time? 10 times. Okay, like this. And then we will multiply it, then we will get answer it. 2 times to 4, 4 times to 8, and 8 times to 16, and 16 times to 30. This is how we get our result. Similarly, and otherwise you can write it like that. You have this problem, then someone asks to you what is the answer of this, then you will answer 32. So you answered like that, by doing like that. You multiplied, you did multiply 2 times 2 till the 5 times. Then you get result 32. So answer of this is 32. So this is like that we can write Instead of writing long more digit, so we can write a short. So result of this and result of this is the same. So these are ways to write different. Clear? So someone asks you 32, how can it be written as in different way? You can say 2 raised to the power 5. Clear? Now let's move on. Some rules which are a product asymptote. Just have a look. The product rule. The product rule. So in the context of exponent rule, we are going to understand about the product rule. This is a part of this. This is a part of this. So product rule says we have a base. Base would be same. For example, 5 and 3. This multiplication is also known as product. And then 5, 10. Otherwise, 4. So simplify it. Question says simplify it. So base should be same. Then it will be possible to say that here the product rule can be used as a rule here. If base is the same. So as we know, base is a common is a taken as a one time because base is the same. Now product rule says that exponents will be added together. After adding, whatever we will get will be what rule of a product. So in the case of a product, this is a product. Okay. Now product rule says exponents. One minute. Hold on. Base will be written one time, and exponents will be added together. So now we are going to add our exponent. This is exponent and this is exponent, and we know this is base, this is base. Now we have how much times? 7 times. So it is the same. Does it make sense? We can write it what 5 3 multiple. How multiple? How multiple times? And then again 5 4 times. And similar, meaning of this is how much time? 5 times. 3 to 5, then 5 will be equal. Here you can see this is a 7 and this is 7. What is the 7? 5 is the 7 times. So meaning of this and meaning of this is the same. Meaning of this and meaning of this is the same. So it can be written as 5 raised to this power 7. Clear? Otherwise, you can write like that as well. But this is a long way. This is going on. So instead writing this like this, we can write what? One number and how much is the times? So 5 times, 7 times like that. Clear? It makes sense because RHS and LHS is equals to. Clear? And to remember, it is written in alphabet of base should be same if and exponents is the same, then okay, and exponents can be different, then we will get what exponent base would be 1 time 1 time, and exponents will be added. So in the case of a product rule, because we have this product, that's why we are adding what our exponent. We are adding exponents. Clear? Now let's move. The percent rule. It says cos the crescent rule is also known as division rule, but division rule we take it as a non-formal. In simple word, we can say division rule, and in formal way we can use it as we can say it as the crescent rule. So meaning of this is we have division. So we, as I told you, base should be different. Base should be equal. Same. This is base hour, and exponent is same. Then it's okay. And exponent can be same and can be different. Okay, like that. So here, try to understand. So base is the same. Exponents are what? Different. It doesn't matter. Exponents are same or not same. It doesn't matter. But base should be same. Now base is the same. We will write how many times? 1 time. So in the context of the crescent rule, we subtract our exponents to each other. Okay. So exponents will be subtracted. In the case of the crescent rule. The crescent rule would say just subtract exponents. Like that. We will get what? Does it make any type of sense? Do you want to see? Just look. This was question. 5 how many times? 2 times. And denominator 5 is how many times? 7 times. 3 to 5 and then 2 more. Okay. So here we can say 1 1 1 will get considered, and we have what? 1 how many times? 4 times. You will understand that it can be written as 5 raised to the power negative 5 exponent. It is happening because of our this number is in denominator and we are writing it in numerator, so that's why exponent will change their hand. So here we changed our hand of exponent. So discussion of this we will understand in the context of negative exponents, and it is also known as what negative exponents. So it can be written as like that. So here you are looking this and this is equal to LHS, this LHS, this was process of LHS, and this is RHS. So LHS is equals to RHS, that's why it is making a sense. Okay, it is making a sense. So for to remember in alphabet it is written as what our base is the same, but exponent is a different. Exponent can be same and can be different. It doesn't matter. So here our base is the same. Our base is a common. That's why we are taking it as a common. So the question rule says that just subtract the exponents of whatever we have. So like that. This is clear. Just have a look. Then we will move on next step. Next is power rule. The power. Next is the power rule. The power rule. What is the meaning of power rule? Here our power which is also known as exponent. Our exponents would be more. Let's say 6 raised to the power 2. Then again 6 raised to the power 2. 2 raised to the power 3. Like that. And question can be like that, but we will come on this discussion, don't worry. First of all, just try to understand. We just try to understand it. Okay, so here we will apply the power rule. Power rule says that just multiply all exponents, whatever we have exponent. We will have to multiply all exponents because of we have what more exponents. That's why. So here we will apply this rule. So it says we will have to multiply all the exponents. So we have two exponents. We are doing multiply it. Then how much we have? 6 raised to the power 6. Does it make any sense? Do you want to see? So this is RHS. Okay, this is RHS. So LHS. If LHS is same this, then we can say, yeah, it is making sense. So this is LHS and this is RHS. So LHS. It is saying that this is inside the bracket is how much time? 3 times. How much time? 3 times. Now we have what? We can apply the quotient rule because we have the product rule because we have product with the exponent. Okay, so just whatever we have, base is the same, that's why base are same. Here we did write one time base, and just we will multiply, we will add all the exponents because we are applying what we are applying for 2 multiple 2. We have how much? 6. 2 4 2 6. So here 6 raised to the power 6 and 6 raised to the power 6. LHS RHS is equals to. So it is making a sense. Okay. This is a proof. Now it is written as 6 is a base. So A, let's say, and we have what? M. Okay. And then again we have what? Exponent M. So Here we will apply this. It says that just multiply all exponents. So here we will multiply. Similar, I would like to take next question, but the exponents would be more. 7, then 2, then 4, then 3. So just to simplify it, so how would we like to solve it? We will just multiply. That's it. Because we are looking that this is here we can apply the power rule. Here there are more exponents. So now we have a chance. We have an option. We have an option. What is that option? Base will be written as it, and the exponents are what? 2, 4, and 3. We are doing multiplied. 7, 4 to z, f to z 24. Okay, like that. We will solve it. This is how we will solve it. We will simplify it. So meaning of this and meaning of this, value of this and value of this is the same. Just this is a way to write it. It was complicated. It was in complicated way, and it is a simple way to write. Okay, just have a look. Then I would like to move on. The next. Power of 0. Power of 0. Power of 0. Power is a 0. Then this is not true, but it is saying if power is 0 of base, let's say like that, then value of this will be what? 1. Value of this will be 1. Whatever you have a base, but base is with 0 exponents, then value will be what? 1. Like that. Value will be 1. Clear? So will it make a sense? So we want to see. We have like that. Okay. So as we know, it will get cancelled out. We will have 1. So this one and this one is the same. But 1 second. Hold on. We are looking what? We need to find out 1. And here we have RHS is equal, but LHS we want to do equal. Let's see, this is a 5. Okay, this is 5. Now we are looking that this is a individual, so we can apply the quotient rule, and quotient rule says that just subtract all exponents with together. So can we write it as we saw in the rule of the quotient rule? So we will have what? 5, 7, 0 will be 0. Then here LHS and RHS, LHS is equal, and RHS is equal. Okay. So meaning of this and meaning of this is the same. You want to write it like this, then you can write. Otherwise you have this problem, then you will get this. And as we did know that it will get cancelled out, we will have what? Similar here. Meaning of this is the same. So value of this will be 1. Okay. And forever plus whatever we have, and then base is with 0 exponent, then value would be 1. Clear? Next is exponent. Next is exponent. Negative exponent. Okay, negative exponent. Negative exponent. Negative exponent. Here. And before this, we saw zero exponent. Now, here you would say what negative. So 5 and then would be like that. This is question. And this is the same thing. It is saying we have exponent which is with negative. So in that case, how would we will how will we solve it? So it says that it can be written as like that one. So here we change the position of a numerator of with of a 5 raised to the power minus 2. So if we change our number who is with negative, then in denominator our exponents would be with addition. Clear? So our hint of mathematics in the case of negative, in the case of this question, our hint will change. Okay. So we didn't write it in the denominator and our exponent was with negative. That's why it is changing because of we did change our position of 5 raised to the power minus 2. So it can be written as like that. Clear? Okay, this is just a way. If you have like that 6 raised, then you will write it 6 raised to the power. If you are writing it in numerator, then you will write like that. Because here you can see this is 7 exponent is with addition. So here we changed this and we did write in numerator, and our exponent 7 was with addition. So here we changed end of exponent. This is a way. So meaning of this and meaning of this is the same. Okay, would be same. Clear? Now 1 by what? 1 by 7. So here we will change end of exponent number. So 7 raised to the power like that. Clear? Clear? No, something different. 8 and 8 power minus 4. So you can write it like that. If you are changing denominator numerator, then this would be what? 4 and this would be 2. Okay. So here we are changing hint of exponents, not a hint of base. So this it can be written as this, and this can be written as this. one more 5, yes, and then 6 minus the 6. So you can be right what we are changing the numerator position. Okay, so we are adding it upward side, so of course this end will change. So here addition is hidden here, and here exponent is with plus, then we will write it with the minus. So value of this and value of this is the same. Okay, value of this and value of this is the same. Just have a look. I will move on. Fractional exponents. Fractional exponents. Fractional exponents. Fractional exponents. Exponents is a fraction. Exponents is a fraction. So here, whatever we have is this. Okay, exponent is a fraction like that. So it can be written as like that because value of 1 by 2 is also written as a root. So value of root is what 1 by 2. Okay. So here 2 is hidden. In the case of root, 2 is hidden here. Clear? So next we have this. So here it is the same. Let's say we have 3 by 2. Fraction. Exponent is in fraction. So here 6 is this. 6 will be written in under root 5. And then 1 by 2 is root. 1 by 2 is root. 2 is hidden here. And 1 was here, 1 was hidden here. Clear? So meaning of my word is denominator will be written here and numerator will be written here as an exponent. So 2 is hidden here and 3 will be written as exponents. Clear? So root 6 is with the 3 exponent. This is how. Similar 4 by 3. So here can we write it 4 1 by 3. Similar, this is the same. Now 7. So here denominator is 3 and numerator is written here, and this numerator will be our exponent, and this is a base will be written in under root. Okay, and our exponent is what? 4. Numerator would be exponent. Clear? Numerator would be exponent and denominator would be our here. Clear? Clear. One more. What? 11. Let's say 11, and it is 14 by 15. Okay. So it says that it can be written our x is in under root. Okay, and denominator of our fraction will be written here, and numerator will be our exponent like that. Clear? Okay. So it says that one more. Do you want to see with addition subtraction? Okay. This is like that. Just this is with so 15 as it. So here our subtraction would be with exponent. That's it. Simple. Now for remember is s is this, and m by n is a fraction with the exponent in exponent, and it will be written of this numerator would be here, and base would be in under root, and m would be what exponent. Just have a look. I would on next. Distribution. Distribute an exponent over over a product. Meaning of this is what? It is saying distribute an exponent like that. Division of an exponent over a product. Base would be here. What base would be? Base can be different and same, but exponent would be common. Question is 2 multiple 3 and it is with a 6 exponent. So it is the same that our exponent will be written with all base. Our exponent will be written with all base. So it is the same because bracket is important in this case. Okay. So 2 is with 6 exponent and 3 is with 6 exponent as well. So it can be written as 2 with 6 and exponent and multiple and 3 with 6. So meaning of this and meaning of this is the same. This is a way just okay. And does it make sense? Do you want me to say? It can be written as how many times? 3 times. 6 times, bro. 6 times. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. So it is saying base is with the 6 times, and we will write 6 times our base. Similar here, it is the same that 2 is a 6 times. How much time? 3 to 5. Similar 3 is with the 6 times. 3 multiple 3 multiple 3 multiple 3 multiple 3 multiple 3. And you would say number of this base and number of this base is same. So LHS and RHS is the same. That's why it is making what we can write. It is making essence. Okay, it is making essence. Here, what? 7 multiple 6 multiple 2 multiple 3 multiple is with the 7 exponent. So we can write it. It is saying 7 is a base and 7 base 7 is with the 7 exponent, 6 is with the 7 exponent, and 2 is with the 7 exponent, and 3 is with the 7 exponent. So it will be written as 6. Okay, like that. This is not answer. This is a way. Okay. Value of this and value of this is would be same. Value of this and value of this would be same. Clear? No. Base, one second. Base is a different. What? Base is a different. Okay, like that. So it is saying A is with M and B is with M and D is with M. In alphabet is written like that. Now second is quotient. Just have a look. Now, this is a statement. This is a statement. Clear? So it is the same. Distribute an exponent of quotient of a division exponent. So we have 7 by 8. Clear? 7. So in this statement, in this case, our base can be different and can be what? Same. And exponent is what? How much? 3. 3. So now it is saying that we can write this base, this 7 with 3 exponent, whereas it can be written with 3 exponent, like that. So here we did distribute it with the exponent. Okay, as our statement was the same. So we did write a different. Clear? So it is making sense. It is saying 7 by 8 and 7 by 8 and 7 by 8 is how much time? 3 times. 7 is 3 times and 8 is yeah. So here we can say this and this is equal. LHS is equals to RHS. It is making sense. It is making a sense. It is making a sense. It is making a sense. You have 8 by 6 with minus 7. So you will write like that. You will write like that. But here we have okay. No, in alphabet. A by B and is with A. It is A. It can be written. Okay. We have just question. We have some question with expression. With the expression. Question is over explain. Okay, just have a look. It can be simplified. It can be simplified. Here we are looking that can we write it like that? Here we can apply the quotient rule. Base is the same. So we will subtract or we will subtract our exponents like that. Okay. Now we have what? 3 minus 6. Now second way like that we can. So here we applied what the quotient rule. The quotient rule. Similar. Here we have 1 by x minus 1. We didn't change our equation. Now we have like that. Yeah, can we write it? When we write the denominator like that, then we change the position of denominator and numerator. Clear? Now we have one is there. Now we have what we can apply the product rule. The acid and x-axis is the same, minus 2 and plus 2 plus subtract would be subtract. Now we have this. Answer of this is the same. So it is the same. We applied the quotient rule. So answer would be this, and we apply. So here we can apply the question rule because here we saw this, and here we applied the product rule because we saw this. Clear? So here we applied two rule in one question. Two rule. Next question I would like to take. Next question. Solve it. How would you solve it? Do you have any idea? Just see. So here we have what the quotient rule we can apply. The quotient rule for acid and y3 and y5. Now we can see we can we can apply what the quotient rule. So because this is the same. So can we write it like that? And then we have okay, clear? Now just see 4y3, okay, and it can be written like that. We did change position of denominator and denominator. Clear? So y raised to the power 3 over 1. And here we are going to add. So here we did as a reciprocal of this. Okay. So here we are 1 is written already we know. Here we have what this is the same. So we can apply what we can't apply the custom rule. We will apply the product rule. Okay. We have now value of this is the same. So in this case we applied the quotient rule, and in this case we applied the product rule. Clear? So from here we saw that we can apply, and from here we saw that we can apply this rule. Did you understand? Can we take next question? Now I am going to take next question. Next question is y3 z5 and 7 0 Just have a look. Can you solve it? Do you have any idea to solve it? Here, just have a look. We have this problem. So here y is a same. So here we are looking that we can apply the question. Similar here, z is the same in division. So we can apply what the question. So y3 and here would be what 7. So we are applying what the question here. Similarly here. Got it? Here we applied what the question to. We applied the question to. Yeah. Now we have left 7 only. Just simplify it and then we have 7. That's it. Clear? So here we applied what the question to. Remember, we applied the question rule. Okay. So it can be solved in other way to use other rule. Yeah, of course. Of course. Do you want to see? Here y3. So this is 1 second. 7 as it. So it can be written like that and similar. We applied what? We applied negative exponent. So here we were exponents with the negative. So here we did right in addition by using addition. Till here already you know. Till here already you know. So here what y3. Here we have y and it will change their position. This is reciprocal, can be written like that as I solved in previous question. Meaning of my word is there is a something and we are changing it. So can it be written like that? Of course, because this is a denominator and we did right to multiply like that. Then we will change the position of a denominator and position of a numerator. Okay. Similar. Z5. Here is what would be Z2. We have left 7. 7 will be passive. So we have what here you can see. We have product. Now we can apply the product rule. We can apply the product rule. Got it? Now -4 and then 7. Just look. Answer of this question and answer of this question is the same. Yeah. So here we applied what? We applied the product rule. The product rule. Clear? Here we applied the product rule. So one question can be made with the two rule. With the two rule. Just have a look. Okay, I am moving on the next topic. Radical root. Rules for rules for radical radicals. Rules for radicals. Question we can have. Clear? Then we have. Then we have. Now, can you explain it? Can you explain it? It is saying this is the rules of radicals. This is the rules of for radicals. These are rules for radicals. So it is saying yeah, with a number we will break down it. So n is a number, but n is a common number. Okay, it is saying we can write it like that. We can write it like that. Base is a different base. We have 2, but this number is 1. So it is saying with this we can write it like that. Doesn't make sense. No. Doesn't make sense. No. Just look. With question, try to understand. Okay. 3. Clear. Like that. 4 multiple 2. This equation, this equation, and this equation is the same. So here it is saying this 3 is with 4 and this 3 is with 2 as well. So it can be written like that. And we have pulled out 3 will be both of base. Clear? So it is a just V. It can be written like that and it can be written like that. Okay? Clear? So in the addition, we, for example, we have 4 plus 2. So it can't be written like that. It can't be written like that. Okay? It will be wrong. It is correct. In the case, there should be what multiplication. There should be product. Then this can be written as like that. Clear? Now, in this case, it is saying that this base is with this number and this base is with this number. like that. Okay. So with the numbers, let's try to understand. 6 and 6. Okay. Okay. 6. 7 by 4. So it is the same. It can be written as like that. Okay. This is just a way. Value of this and value of this will be equal. Okay, will be equal. So it is saying just this value of this number can be written as like that. Clear? These are rules for radicals. This is radicals. Okay, and it is also said rule. Clear, brother? Okay. Till here we are clear. Clear. So here we are looking at a divisor. We are looking divisor. So we have this like that. This. Then we can't write it what like that. 6, 7. Then 6. It will be wrong. It will be wrong. If you are writing this like that, 3, 6, then it is simplified. So it can't be written like that. Okay. It can be written like that. This is solution. Okay. This is right. In the case, if we have a subtraction basis with subtraction addition, then we can't write like that. Clear? We can say there is no rules of addition and subtraction in the case of radicals. So next. This. It is saying what is it saying? This. This, brother. And question on this will be solved. We solve. So it is saying this numerator, this denominator will be written here. Okay. And m, which is a numerator, will be used as exponent. Here, exponent like that. So this can be written like that. Clear? This is base, and this is denominator, and this is the numerator. Numerator will be used as exponents in this case. Clear? And we solved the question on this rules 7 2 by 3. So here 7 is the base, and 1 by 3. So this denominator number will be written here, and numerator will be used as exponent. Clear? As exponent. So it can be written like that, and it can be written as like that. Do you understand? These are rules for radicals. Radicals, which means rule. We have question. We have question. Question, which is what? Compute 25. Okay. Divide. So here we are looking that we have what? Fractional exponent. Yeah, we have fractional exponent, whereas we have negative exponent. Whereas we have radicals. It can be written as like that. This is okay. So 25 as it, and 2 is what? Denominator? Yeah, numerator by denominator. Denominator will be written here, and numerator numerator is minus 3 will be used as exponents. Clear? And it can be written like that. We have negative exponents, and as we saw in the case of negative exponents, 25, 25, yeah, as it. So here we are changing. We change what we did change position of denominator and exponent, numerator and denominator value numbers. Okay, numbers. So similar, if we are changing position of denominator and numerator, then we will change what hint of exponent as well. Clear? So here will be written like that. So it can be written as like that, and it can be written as like that. Clear? Clear with me? This is a equation for practice, and we saw it. There is a room. There is room. Right. Now we can solve what can it like that we can write 25, and 3 is denominator will be used as denominator. So we know 2 is hidden. So 1 by root 25, and then we have will. So here we have resulted. In a root we have, if we have resulted, then it is saying this 25 is resultant of a base, and base was 3 times. So what is the base? So here we are removing what the root, then we will write what 5. Clear? And it can be also written 1 by what 5 times 25, 25 is 125. 125. Clear? 5 times 25, 25 is 125. 5 times 25 and 25 is